Hello guys, welcome you for today's class. In previous class, we had derived the mathematical relation for cyclic relationship and reciprocal relationship. Today, this relationship we will use in this equation. We have also derived dz equal to mdx and plus ndy. So that equation we have used in this way: del m over del y at constant x equal to del n over del x at constant y. This relation we use for derivation of the Maxwell relations. So Maxwell relations is nothing but relation of the temperature, pressure, volume, and entropy to develop thermodynamic potential. Four thermodynamic potential. These are four thermodynamic potential. Thermodynamic potential. These are Gibbs energy function G, F, U, and H. These are per unit mass. Gibbs energy function per unit mass, Helmholtz energy function per unit mass, internal energy function per unit mass, and enthalpy, total heat energy per unit mass. You can write H equal to H upon M, E equal to capital G, G upon M, and U equal to capital U upon M, F equal to F upon M. So these terms we have, these are energy potential, thermodynamic potential per unit mass. So that we are going to define by using this property of the mathematics. So first we take internal energy U. You know that internal energy del Q dq equal to du plus pdv. This equation we know that heat given equal to change of internal energy and work done at constant pressure. So you can write dq equal to TdS. dq equal to TdS equal to du and plus pdv. So du equal to TdS minus pdv. This is your first relation. du equal to TdS minus pdv. du equal to TdS minus pdv. Second, H equal to, you know, H equal to U plus PV. H equal to U plus PV. Internal energy plus pressure, product of pressure and volume. So DH equal to DU plus PdV and plus VdP. Differentiating it, VdP, and put value of du from equation number 1. So DH equal to TdS minus PdV and plus PdV and plus VdP. So you remove this PdV. Sorry, something mistake I committed. Sorry. Putting value of du, DH equal to TdS minus PdV and plus PdV and plus VdP. Remove this one. So DH equal to TdS minus VdP. This is second thermodynamic relation. DH equal to TdS minus VdP. And third one. Thermodynamic potential is Helmholtz function G. G can be defined as U minus TS. So dg equal to du minus TdS minus S dt. Putting value of du from equation number 1. So du equal to TdS minus PdV minus TdS minus S dt. Removing TdS. So dg equal to minus PdV and minus F dt. This is the third thermodynamic potential. Writing all these thermodynamic equations. First one is a du equal to TdS and TdS minus PdV. PdV. Second, dH equal to TdS plus VdP. Third one, dF equal to minus PdV minus PdV minus F dt. And fourth I will define Gibbs energy function. That is a Gibbs energy function. Fourth is G. It is defined as H minus Ts. Difference of enthalpy per unit mass minus product of, it is defined as H minus Ts. Enthalpy per unit mass minus product of temperature and entropy. So dg equal to, differentiate it, dg equal to dh minus tds minus sdt. Putting value of dh from equation number, this is equation number 1, equation number 2, equation number 3, from equation number 2. Putting value of dh from equation number 2. So dg equal to ds TdS plus VdP minus TdS minus SDT. Removing TdS, so dg equal to VdP minus SDT. This is the fourth equation. dg equal to VdP minus SDT. So these are four equations that we have. These are four equations. You can see these are four equations. On that basis, we have defined this equation. dz equal to mdx plus ndy and del m over del y at constant x equal to del n over del x at constant y. This relationship will apply for all these four equations. So we get a relation in Maxwell equation form, differential equation form. So taking first one, relating this one and this one, you see d equal to TdS minus PdV. By making analogy, m is equal to t and n equal to p and x equal to here and y equal to here. So relationship equal to क्या होगा? This relationship equal to del t over del v at constant s equal to minus del p over del s at constant v. This is relation equation number 1. This is Maxwell relation equation number 1 corresponding to this one. Now taking this equation, second one, dh equal to TdS minus VdP. So corresponding, and making analogy with this one. So this one, by taking analogy of this equation, so del t over del p at constant s equal to, this is this was plus sign. Here you see this is plus sign. So del t over del p at constant s equal to del v over del s at constant p. Del v over del s at constant p. This is second relation. Second Maxwell relation. In this way, we can write all four equations. Again, writing this one. Writing all differential equation at one place. This is del t over del v at constant s equal to minus sign del p over del s at constant v. Corresponding to equation, this one, first equation. Corresponding to first equation. And corresponding to second equation, you see del t over del p at constant s equal to del v over del s at constant p. This is corresponding to second equation. Now taking third equation, this one, df equal to minus pdv minus fdt. So there are two negative signs, so all terms will be in positive. So taking del p, just see here, del p over del t at constant v equal to del s over del v at constant del s over del v at constant t. Equation number third. Taking this equation, dg equal to vdp minus fdt. So here this equation become by taking analogy. So del v over del t at constant p equal to del s minus sign del s over del p at constant t. This is equation number 4. So these are all four Maxwell relations. This relation is corresponding to this one. This relation corresponding to this one. This relation corresponding to this one. This relation corresponding to this one. So these are linear equation, and these are corresponding differential equation in Maxwell form. These are equations. These are four equations which are very important in many competitive examinations, in civil service examination, IES Indian Engineering Service examinations, even in GATE examination. These four equations are very useful. Sometimes alternative questions you see, because lot of manipulations is there. You have to remember. If you remember these four relations, then you can derive these four equations. So these four equations must you remember, or you can derive. Otherwise, you will always make a mistake in relating these four equations, because in IES examination, objective type examination, and GATE examination, various competitive examination, various public sector examination, these relations are asked to find which one is wrong. You can put here t here and v here. This equation become wrong. Put p here and t here. Anything you can. Lot of combination are possible in these four equations. These are cardinal of the applied thermodynamics. You must remember how to derive these four equations. These are going to make you very helpful in understanding other further TdS equations. We derive TdS equations, Cp minus Cv equal to R. Lot of combinations are there. Once you understand these four equations, all combinations you can derive, because any kind of combination can be formed on the basis of these four relations. And pressure, temperature, volume, and entropy can be expressed in terms of these four relations. These are very important relations. I think this discussion you will find very interesting to understand applied thermodynamics and further Clausius-Clapeyron equation, Joule-Kelvin expansion, Joule-Kelvin coefficient, phenomena of throttling we can explain on the basis of these four relations. Thank you very much for watching. Please make a comment and like and subscribe it. Thank you.